Hello everyone. So in our last video we discussed about that how we can merge two sorted arrays in Java. We discussed about the idea that how we can merge two sorted arrays. So in this video we'll see the step-by-step demonstration of the algorithm. But before we start, in case if you are new to my channel, then please subscribe to my channel so that you never miss an update. So here you can see that this is the algorithm to merge two sorted arrays, array1 and array2, into a result array and simply return the result array from this method merge. So let's see the demonstration of this algorithm step by step. So initially when we call this merge method, we pass in the two sorted arrays, array1 and array2, and we also pass the length of these two arrays with a variable as n and m. So n will correspond to the length of array1 and value m will correspond to the length of array2. So when we call merge method, here you can see that for this example we are taking two arrays which are sorted in ascending order having length as 3. So let's say we are providing these two sorted arrays having length as 3, and here you can see the elements are sorted in ascending order in both the arrays, and now our task is to merge these two arrays into a result array and return that result array from this method. So the length of these arrays are denoted by n and m having values as 3. So in the first step, as we want to merge these two arrays, all the elements should be part of the result array. So first we create that array by name result, and the length of that array would be n plus m because we need to merge these two sorted arrays and our result array should contain all the elements of both these arrays. So after this line gets executed, we are provided with this array whose length is 6. Moving ahead, and as we discussed in our last video, the idea behind this algorithm is we create 3 pointers I, j and k. We'll initialize it with 0 value. Now what these pointers are? The pointer I will traverse array 1 starting from 0th index, so we have provided value 0. Pointer j will traverse array 2 starting from 0th index, and pointer k will traverse the result array starting from 0th index. So here you can see the purpose of these 3 pointers are different. So in this algorithm, at any instant we are comparing the value stored at ith index with the value stored at jth index, and whichever the value is smaller, we are simply updating into the result array at kth index. So these two pointers are used for comparison, and this pointer is used to fill this array. And the filling of this array is sequential, where we place in elements one by one and will increment k one by one. And similarly, this comparison also sequential. We are finding the minimum value at each iteration and we are simply updating into the result array. So here, at the start of this algorithm, we are providing this while loop. Now why we have provided this while loop is because we need to compare the value stored at ith index and value stored at jth index. So it simply means I will traverse the array 1 and j will traverse array 2. So in order to perform this traversal and comparison, we are providing this while loop, and inside this while loop we have provided two conditions. One is I should be less than the length of array 1 and j should be less than m, which is length of array 2. Now why we have provided this condition is because as we are comparing and incrementing values of I and j, which you can see here, so there can be a chance that j goes out of bounds for array 2 and I goes out of bounds for array 1. So when any of this pointer will exhaust its respective arrays, we'll simply exit this while loop because there are no more elements left to be compared between these two arrays because one array is already exhausted. So therefore we have provided these two conditions. So at the start I is pointing to 0, j is also pointing to 0, I is less than 3 and j is also less than 3. So therefore this while loop condition comes out to be true. Now in the while loop we are comparing that whether value at ith index for array 1 is less than value stored at jth index for array 2 or not. So here you can see, so we are comparing 2 with 3. So here you can see 2 is less than 3, so this condition comes out to be true. So therefore if block will be executed. Now as we have found a minimum value among these two values and we want to merge these two sorted arrays into this result array in sorted form, then what we do is we simply update the value at ith index for array 1 into this result array at kth index. So 2 will come here. Moving ahead. Now as we have used this value, so we'll increment I by 1. So currently I is 0. I will become 1. And after this if else, we will increment k by 1 because we have filled this position here. So now we need to go to next position to get the next element. So k becomes 1. We'll check both these two conditions. So 1 is less than 3 and value of j is 0. So 0 is also less than 3. So this both the condition comes out to be true. Now we'll again compare value at ith index for array 1 with value at jth index for array 2. So which is we are comparing 5 with 3. Now here you can see 5 is not less than 3. So therefore this condition comes out to be false and else part will be executed. So in the else part, as 3 is less than 5, we'll simply update value of 3 to the result array. So here we are assigning value stored at jth index for array 2 into result array at kth index. So 3 will come here. Now as we have used the value 3, we'll increment j by 1. So j becomes 1. And we are not touching I because we need to still get this value 5 and store it somewhere into the result array. So I will simply point to the same index. We'll increment k by 1 because we have filled its position. So for the new value, we'll simply go to its next index. So k becomes 2. 1 is less than 3 and 1 is less than 3. So this both the condition comes out to be true. We'll compare value at ith index for array 1 with the value at jth index for array 2. So here we are comparing 5 with 4 now. And here you can see 5 is not less than 4. So this condition comes out to be false. And in the else part, as we have found the minimum value as 4, we simply update 4 into the result array by this assignment. And as we have used this value, we'll increment j by 1. And we have filled this position, so we'll increment k by 1. K becomes 3. Here still I is less than n and j is also less than m. 1 is less than 3 and 2 is also less than 3. So this both condition comes out to be true. We'll now compare 5 with 9 because those are the values pointed by I and jth index. And here you can see 5 is less than 9. So therefore this if block condition comes out to be true. So now it's time to update value 5 into the result array. And as we have updated value 5, we'll increment I by 1. So I becomes 2. And as we have filled this position, we'll increment k by 1. So k becomes 4. So still this while loop condition comes out to be true because I is less than n and j is also less than m. We compare these two values 7 and 9. We found that 7 is less than 9. So therefore this condition comes out to be true. So we simply update value stored at ith index in array 1 into the value 8th kth index for result array. So 7 comes here. And then we'll simply increment I by 1. So I becomes 3. So here you can see now I has crossed the boundary for array 1. We have used this position, so we'll increment k by 1. K becomes 5. So friends, now here you can see that array 1 is already exhausted. So this condition I is less than n, where 3 is not less than 3. So therefore this overall condition will come out as false and this while loop will terminate. So here you can see whenever any of the array gets exhausted, we'll simply break from this while loop. And then our execution point will reach here, where we are encountering two while loops. So friends, here you can see that there can be a chance that array 1 gets exhausted first or array 2 gets exhausted first. So when this while loop will terminate, we are not sure that which array gets exhausted first. So therefore we have provided these two while loops. So here, let's say for example array 2 gets exhausted first. So if array 2 gets exhausted first, there can be leftover elements in array 1 which needs to go into the result array. So we are providing this while loop where we are simply traversing I to complete the array 1, get those elements from array 1 and simply fill it in the result array. Because as both the arrays are sorted, we are simply copying the leftover elements from the respective array into the result array. So this while loop is when array 2 will get exhausted, and this while loop is when array 1 will get exhausted. So currently for this example you can see array 1 got exhausted. So this while loop will not get executed because the condition here is I should be less than n. So 3 is not less than 3. So therefore this while loop won't get chance to execute because array 1 is already traversed completely. And we know that there are leftover elements in array 2 because j is less than m, 2 is less than 3. So whatever elements are left over in array 2 will simply get copied into the result array because those elements are already sorted. So we'll simply store value 9 into the result array by this assignment. And after doing this assignment, here for this small example you can see that there was only one element, so we simply updated one element here. But let's say if there are many elements, and as these arrays are sorted, so we can simply copy those leftover elements directly into the result array because there are no elements left for array 2 to get compared with array 1 because array 1 is already exhausted. And same thing goes when array 2 gets exhausted and there are leftover elements in array 1. So these two for loops are important because they simply copy the leftover elements from their respective arrays to the result array. And there can be multiple elements which are left over, so therefore we are providing this while loop. So at the last step of this while loop, we are incrementing j by 1 and k by 1 because we have migrated value 9 into result array. So j will now get incremented by 1. J becomes 3, which means now j has crossed the boundary of array 2, and will also increment k by 1. So k becomes 6. So which means k has traversed the result array completely by filling out each and every position. So now we'll again compare whether j is less than m or not. So here you can see 3 is not less than 3. So therefore this condition comes out to be false, which signifies that we have completely migrated all the elements of array 2 to result array. So friends, finally here you can see that we have merged these two sorted arrays into a result array which is also sorted. So finally we'll return result from this algorithm. So friends, in this video we discussed the algorithm that how we can merge to sorted arrays. So in case if you find this information useful, then please like, comment, share and subscribe my channel. Thanks, have a nice day.